All right, this is geometry. Some homework help for chapter 11. I'm on page 430. We're going to start problem 7 on 11.1. It says, how do I know it? How do I know what? How do I know that EF is the geometric mean between, it has to be between segments FP and EP? That has to be the answer for number 6. How do I know that? It's because of Pythagorean's theorem. All right, so that's number 7. 37 on page 432. 37 says, find the area of the square to the nearest square inch. So you have to go back to the previous page, and it looks like the diameter is 12 inches. So the diameter, so this is 37 on 11.1. If the diameter is 12, 37 asks for the area of the circle. So area, I'm a little close here, aren't I? Area is pi r squared, but that's 36. So it's 36 pi square inches. You just put that in your calculator. I would have you leave it like that. All right, 38 is the next question. All right, I'm going to draw the triangle. All right, so we have OBC. I'm just going to draw OBC, and then I'm going to add BA. So this is OBC. That's a right triangle. And then we have A, and that's a right triangle. And so it says OA, which is a leg in this triangle, all right, over OB, which is actually a leg in the larger triangle, okay? You see that? Leg here, smaller triangle, this triangle, leg there, bigger triangle, equals, all right, so this is in the smaller triangle. This is in the larger. So it looks like the numerator's in the smaller triangle, the denominator's in the larger. OB in the smaller triangle, which is in that triangle, it's the hypotenuse. So we need the hypotenuse in the bigger triangle. It's got to be OC. All right, now 51. 51. All right, so 51 in lesson 1. We have this triangle. Again, we've got to have two triangles. It looks like the altitude of the leg roll, right? This is X, Y, Z. And it says find Z. I'm going to use the altitude rule. All right. So Z goes here. Part of the hypotenuse goes here. The other part goes there. All right, I'm going to cross multiply. It's Z squared equals X times Y. Just take the square root. Z is the square root of X times Y. All right, now lesson 2, we're going to go to number 29. So I'm going up to page 437. All right, number 29. Maybe I'll do these in 2 videos, 1 through 3, and then there's a lot of them. Okay, 29. What is the length of side BC? All right, B has the coordinate points x2, y1. C has the coordinate point x2, y2. Length is distance. Distance is the square root x2 minus x1 squared plus y2 minus y1 squared. All right? You just label your coordinates. We'll label these set 1, even though they're sort of similar. Okay, I'm going to use a different color marker. And we'll label this. This is going to be x1, y1. This one's going to be x2, y2. Notice our x's are going to cancel out. It's going to be x2 minus x2 squared. That's 0. y2 minus y1 squared. So that's 0. So we end up with the square root of y sub 2 minus y1 squared. The square root of anything squared is just what's under the radical. So the distance is y2 minus y1. Better mark through these as I finish them, huh? All right, number 30 says, what does number 30 say? Why does it follow the distance? That's the formula. Number 30 is actually the formula. All right, 11.3, number 19. Now I am moving number 19, page 444. Page 444. Maybe I'll get through all of this in one video. All right, number 19, we have this triangle. There's my right angle. This is x, 15, y. Over here is 30 degrees, and that's 60 degrees. All right. So we have a 30, 60, 90. The Pythagorean triplet is 1. Square root of 3, 2. Opposite 60 is 15. Opposite 30 is x. The hypotenuse is y. We always go back to 30. To get from 60 to 30, you divide by square root of 3. All right, 60 to 30, you either divide by square root of 3 or multiply by square root of 3 over 3. Those have the exact same value. All right. So I'm going to take 15 times square root of 3 over 3. So it's 15 square root of 3 over 3, but that can be simplified. We can simplify terms that are multiplied. So it's 5 square root of 3 is x. To get from 30 to opposite 90, I multiply by 2. So y is just 5 times 2, 10. The square root of 3 stays. All right, that's number 19. Number 41 jumps to page 446. All right, 41 says, use your answer in 40 to explain the 7/8 rule. It says that the distance CD, that's the distance right there, CD, is 7/8 of the distance AB. Well, AB is x. And the distance of CD is square root of 3 over 2x. So are those the same values? All right, so we would have square root of 3 over 2x is 7/8 x. You could divide by x. Is the square root of 3 over 2 similar to 7/8? And it is. If you look at your decimals, they're very close in decimal places. So that's the 7/8 rule. All right. Now, jumping to 11.4, I'm going to keep going. 11.4, 7 through 9. All right, this is all calculator. I'm just going to write them on the board. 7 says the tan of B is 0.1. Tan of C is 24. And we have to solve for B and C and then D. The tan of D is 1,000. They're wanting us to solve for the angle. It's the tan of an angle equals the ratio for the tan opposite over adjacent. You have to do the inverse. You have to swap your x's and your y's. It's the inverse tan, 0.1 equals B. So we're going to do that for all of them. I'll just show you on my calculator. All right. All right, so you do shift tan right here. Shift tan, 0.1 equals. All right, so it's 5.71 degrees. Same thing for the next one. Shift tan 24. Shift tan 24 equals 87.61 degrees. Next one. All right, so this is 7, 8, and 9. All right. Shift tan 1000 equals 89.94. All right, that's 7 through 9. Number 30. We have a triangle. There's the right angle. 30, Paula. 30. Oops, this is actually 31. I'm going to go back to 30. 30. I was looking at 31. All right. The triangle looks like this. It's X, 10. We have 44 degrees. We have 46 degrees. Doesn't matter which one you use. I'm going to use this one. In terms of 46, we have the opposite and the adjacent side. That tells me to use the tan, the tangent. So it's the tan of the angle equals the opposite over the hypotenuse. You multiply by 10. And you do that in your calculator. 10 times the tan of 46. Let me clear this out. It's 10 times tan 46, make sure that looks right in my calculator, equals. All right, that's the length of the opposite side. It should be bigger than 10 because that angle's bigger. It's 10.35. It's a little bigger. All right. Number 31, we have this triangle. 14, X, 55, 35 degrees. Doesn't matter which one you use. I'll use the 55 degrees this time. That's opposite. That's adjacent. So it's also the tan. Tan of 55 degrees equals the opposite over the adjacent. I just multiply by 14 on both sides. And that's 14 times the tan of 55. And you get the length of the side. All right. That's 31. Now we're going to 47. 47. Got to turn a page. 47 wants to know. Okay. All right, so we have this triangle. We have two triangles. There's an altitude. This is A, C, D, B. It says the distance B to D is 1,000. That's like the camera. So the length of that is 1,000. It says A to C is 130. Well, this is half of it since it's an equilateral triangle. This is half. And the question is angle A, B, C. Well, these two angles have to be equal because the altitude not only bisects a isosceles triangle. All right, so this has got to be half of that. What's half of 130? 65. So if I get one of these angles, I'm just going to multiply it by 2. So that's what I'm going to do. We'll label that angle theta. In terms of theta, I have the adjacent and I have the opposite. So I'm going to use the tan. So the tan of theta is the opposite over the adjacent, but because I'm solving for the angle, I have to use the inverse. Inverse tan, 65 over 1,000. Excuse me, Cuddy, out. Cuddy, out. Get out. Yes, Cuddy is going into rooms he has no business going into. Okay, so you hit shift tan, 65 divided by 1,000. All right, so that's 3.718. I'm just going to multiply it by 2 because it's twice that. So it's 7.4. What did it say to the nearest? Whatever it said. All right, that was 47. To the nearest 0.1 degree. 7.4 degrees. All right, that takes care of lesson 4. Let's go to lesson 5. Number 38. Lesson 5. Number 38 is on page 458. 38 says, use 3060, make sure I'm on lesson 5. Use 3060 right triangle theorem to explain why the expert wrote what is true for a given length of a line. Okay, I don't know what the expert wrote, but the hypotenuse in relationship to L is always twice of H. It says at a line angle of 30 degrees, the kite is half as high as ever. Yes, because it's 30, 60, 90. All right, because this is always half of that. The kite is half as high as the length of the string. All right. Because of your Pythagorean triplet. 1, square root of 3, 2. All right. Number 40. Now we have a kite actually flying. Given that the angle of elevation was 42 degrees. All right, so if that's the kite in the air, right, the kite is up here. And the angle of elevation with the ground was what? 42 degrees. When the line was 21,600. Oh, how high? How high was the kite? Above the ground. All right, so we have opposite over hypotenuse. Opposite. I wrote an H. I said opposite and wrote an H. It's the opposite. Opposite over hypotenuse. Ah! There we go. Boards are falling. Okay, we're letting them fall. So that's the sine. The sine of 42 degrees is the length opposite. I'm going to draw a line through it so it's not 0. Over 21,600. So we just multiply by 21,600 and get the height. All right, so it's 21,600 times the sine of 42. That's how high it is. 14,453 feet. Was that number 58? No. That was 40. Now we're going to 58, which is now on page 460. All right. Did I say 58? All right. So 57, the sine of angle 2 is D over H. And angle 2 equals angle 1 because of the parallel line. All right. So 58 says, find the measure of angle 1 if D minus W equals 1/2 H. Okay, I'm going to put H is 2D minus 2W. I just multiplied both sides by 2 so that we have the sine of angle 1. Since they're equal, the sides have to be the same. So I'm going to leave it D, but for H, I'm going to put 2D minus 2W. You could break that down to D over 2D minus 2D over 2W. D over 2W. That's 1/2 minus D over 2W. And you could do the inverse sine. You can't obviously put that in your calculator. Is equal to angle 1. All right. Now, lesson 6. All right. Lesson 6. Number 28. All right, lesson 6, number 28. I'm on page 465. Find the distance. So 28, we have B is -1, 4, and C is 10, 7. All right, let's find the distance. You have to just use the distance formula. I'm just going to mark that, label that X1, Y1. This is X2, Y2. Distance is the square root, X2 minus X1. Minus a negative is plus squared, plus Y2, 7 minus Y1, 4 squared. So that's 11 squared, that's 121. That's 3 squared, which is 9. So that's the square root of 130. Let's see if we can, that's 10 times 13. I think that's final answer. Can't be simplified. All right, 29 is the same, I believe, when I glance. 29 just has different points. C is now 10, 7. C's point is 10, 7. I guess it hadn't changed, huh? And D is 3, -2. Label your points. One set's 1, one set's 2. Distance is the square root. 3 minus 10 squared plus -2 minus 7 squared. That's -7 squared, which is positive 49. That's -9 squared, which is positive 81. That's 10. And it's the square root of 130, huh? It's the same. All right, 28, 29. Now we go to 55. 55. 55 is easy. It says, why is triangle ABC similar to triangle DEF? It has to be angle, angle. Angle, angle. That's the only reason. And the next one, 56, they write a proportion. Why can I write that proportion? Because corresponding sides of similar triangles are proportionate. All right. Now 62. 62 says this. Why is AD over BD equal to BD over DC? BD, that's your altitude. It's the altitude rule. Because AD is part of the hypotenuse and DC is the other part of the hypotenuse. So it's the altitude rule.